Hello, you are welcome. Now the question here says a ball is thrown upwards with a velocity of 40 meters per second at an angle of 60 degrees to the horizontal. Calculate A, its vertical velocity after it has reached a vertical height of 35 meters in its upward motion. Then the second question says B, its height after it has covered a horizontal distance of 32 meters, and we are given acceleration due to gravity as 10 meters per second square. Now for us to solve this, let me start with question A. The first thing for us to do is to state the parameters that were given in the question. Now the first thing we are given there is the velocity, which is the initial velocity 40 meters per second. And that initial velocity is represented by letter U. U is equals to 40 meters per second. And then the next thing is the angle of projection. It is projected at an angle of 60 degrees to the horizontal. So that is theta for us. So theta is equal to 60 degrees. And then after that, we are asked to calculate its vertical velocity after it has reached a vertical height of 35 meters. So that means that vertical height is V subscript. That vertical height is H. So after it has reached a height of 35 meters, and then we have to find the vertical velocity, which is V subscript Y. That's the vertical velocity that we're asked to look for. Now, for us to solve this, we can apply an equation of motion that directly relates U, theta, H, and Vy. And then don't forget acceleration due to gravity, which is G is equal to 10 meters per second square. So we have to get a formula that has U, that has H, V, and G. And don't forget, we have to take, this is the vertical motion, so we have to take the vertical component of this velocity using this angle. So the right formula to apply here is V subscript Y square is equal to U sine theta all squared minus 2GH. So this is the right equation of motion to apply. Don't forget, this equation of motion is similar to V square is equals to U square minus 2GH. Now we are using sine theta because we have to take the vertical component of the velocity. So that is why we are adding sine theta, because this time it is not projected vertically upward, rather it is projected at an angle to the horizontal. So that's why we are adding sine theta to get the vertical component of its velocity. And that is what we have to use in the equation. So I can go on by substituting values. Don't forget, we are looking for the vertical velocity. So the value of U is 40. So I'm going to say 40 times sine. The angle is 60 degrees. Sine 60 all squared. Then minus 2 times G is 10. And then multiply by the vertical height H, which is 35. Multiply by 35. And then if we walk further, we have 40 times the sine of 60 degree is 0.866. 0.866 all squared minus 20 times 10 is Sorry, 2 times 10 is 20, multiplied by 35 will give us 700. So 40 multiplied by 0.866. When we square it, we'll have the approximately value of 1,200. So it will give us 0.9, but when we approximate it, we have 1,200. And then minus 700. Then that will give us Vy square is equal to 1,200 minus 700 will give us 500. And then from there, to get the value of V subscript y, we have to take the square root of both sides. So I can simply take the square root of this. So this square takes care of this root sign, and I have V will be equal to, that is V subscript y will be equal to, I also take the square root of this side because I'm taking the square root of both sides. So the square root of 500 is going to give me my value as 22.36. So I have 22.36 meter per second. This is the value of the vertical velocity reached at that particular horizontal or vertical height. So this is the value. Don't forget, the question says that we should find the value of that vertical velocity after it has reached a height of 35 meters. So that is our answer, 22.36. Now the second question, B part of the question, says we should find its height after it has covered a horizontal distance of 32 meters. So we have to find the height after it has covered a horizontal distance of 32 meters. So now the formula we are going to apply here is to use the formula that says S. Let me write question B. S is equal to ut cos theta. This formula is going to help us to get the time at which it has reached that horizontal distance of 32 meters according to the question. Don't forget, the question says we should find the height when it has reached a horizontal distance of 32 meters. So this S is giving us the horizontal distance and is equals to u cos theta. This u cos theta is the horizontal component of the velocity and then multiply by time. So let's find the time first before we calculate the height. So 32 is the horizontal distance from the question, and it's equal to the value of u from the question is 40 times the time that we're looking for, then times cos the angle, that is cos 60, because the angle of projection is 60. So that gives us 32 is equal to 40 times t times 0.5. The cosine of 60 degrees is 0.5. So I now have 32 is equal to 40 times this is 20 multiplied by t. That gives me 20t. So I can simply now divide both sides by 20. So I divide this by 20 and I also divide this by 20. So this 20 will cancel 20. So I'm left with t. So let me write the t first. So I say t is equal to, then 32 divided by 20 will give me 1.6. So the time for it to attain this horizontal distance of 32 meters is 1.6 seconds. But that is not our final destination because we are asked to find the height. Height is what the question asks us to find. So for us to find the height, the formula to apply now is to simply use h, which is the right formula now because we are looking for height. H is equal to ut sine theta. This time we have to use sine because this time is the vertical height. Then minus, don't forget we are using minus in all our equations because it is going upward, which is against gravity. So minus half gt square. So this g is giving the negative value because it is going against gravity as the object is thrown. So now I can go on and substitute values. The value of our u is 40. That's the initial velocity is 40. Multiplied by the time, which is 1.6, as you can see here. The time we just calculated now is 1.6. And then multiply by sine 60 degree. That's the angle now. Let me put this part in bracket. And then multiply by half times 10. Acceleration of the gravity is 10. So 10 multiplied by 1.6. The time, 1.6 square. Don't forget, the time is 1.6. So going further from here, I can move on and say is equal to 40 multiplied by 1.6 multiplied by sine 60 is 0.866, and then multiply by 2 here, 1, 2 in 10 is 5. So I have 5 multiplied by 1.6 times 1.6. That is 1.6 times 1.6, because it is square, 1.6 squared. So I can move on. Sorry, this is minus. This is minus, and then this is minus. Sorry for that mistake. That is minus here. So minus and minus. So it will simplify to give us, if we multiply the whole of this, it's going to give us 55.424. 55.424 minus, if we multiply the whole of this, I put it in brackets. If we multiply the whole of this, it is going to give us 12.8. 12.8. So finally, if I subtract the two values, I'm going to have h, that is the height now, as 55.424 minus 12.8 is going to give us 42.6, approximately 42.6 meter. So this is the height that it has attained after traveling a horizontal distance of 32 meters. So don't forget, the question asks for the height it has attained after traveling a horizontal distance of 32 meters. So that is the height in the final answer, which is 42.6 meters. Hope you enjoyed this video. Please don't forget to like and share this video so that others can really learn from it. And do not forget to join me in my next video. Thank you for watching.